What if everything we've ever believed about the universe, its origins, its structure, its rules, turns out to be profoundly flawed? What if the very fabric of our understanding is built on assumptions that are now beginning to unravel under the pressure of new evidence? A set of recent discoveries has emerged that might just upend everything we thought we knew. It all began with a subtle but deeply compelling signal, so faint it could be dismissed, yet so persistent it demands attention. This signal suggests that the architecture of our cosmos may not be the simple symmetrical expanse we've long imagined. Instead, it may be far more peculiar, complex, and perhaps even guided by an unknown principle we have yet to comprehend. The mystery first began to take shape when astronomer Leo Shamir conducted a study involving over 260 galaxies using data gathered from one of the most advanced deep space surveys ever undertaken. At first glance, the project appeared routine, another analysis of distant celestial structures. But what Shamir noticed defied conventional expectations. He wasn't merely observing isolated phenomena like a particularly old galaxy or a bright supernova. He discovered something bigger, a consistent pattern, an unevenness in the way the earliest galaxies rotated. Roughly 2/3 of them appeared to spin in the same direction clockwise, while only about 1/3 spun the other way, counterclockwise. This imbalance may seem minor, but it cuts to the heart of one of cosmology's most fundamental principles. According to the Standard Model, the universe should be isotropic and homogeneous when viewed on large scales. In simple terms, it should look the same no matter where you look or in which direction. The spin bias found in these early galaxies contradicts that assumption. If the universe were truly uniform, the distribution of galactic rotation should be random and balanced. But this isn't what the data shows. Instead, it hints at an asymmetry, something unexpected and possibly deeply meaningful. Such a deviation from expected behavior leads to questions that border on the philosophical. Could the universe have been born spinning? Could there be a directional preference embedded in the cosmos from its very inception? These are not just abstract questions. They point toward some of the most mind-bending hypotheses in modern theoretical physics. One such idea is known as black hole cosmology. It suggests that black holes are not merely destructive gravitational pits, but creative engines, gateways to new universes. The theory proposes that what we perceive as a black hole in one universe may, under certain extreme conditions, give birth to another universe on the other side of the event horizon. In this framework, our universe might be the result of such a cosmic event. Rather than beginning with a singular Big Bang from a point of infinite density, as the traditional model asserts, our universe may have sprung from the collapsed remnants of a previous cosmos. This perspective is supported by a hypothesis sometimes called Schwarzschild cosmology, a theory that has been around for decades but has recently gained renewed interest. According to this model, the matter within a black hole doesn't simply collapse into a singularity, but rebounds in a kind of explosive bounce, creating a new universe sealed off from its parent by the boundary of the black hole. Physicist Nikodem Popovsky has been one of the more vocal proponents of this idea in recent years, arguing that it not only explains the uneven galaxy rotations, but also offers a new way to think about the very beginning of our universe. If this theory is accurate, then what we call the Big Bang might not have been the beginning at all. Instead, it could have been a transitional moment, a bridge between two epochs, triggered by the collapse of an older universe. This concept challenges the linear timeline we've long assumed and opens the door to a far more intricate and cyclic model of existence. Of course, not everyone agrees. Some scientists caution that this perceived galactic rotation imbalance might not be real at all. It could be the result of observational bias or a misinterpretation caused by our own location and movement within the Milky Way galaxy. If our perspective is skewed in even a small way, it could influence the way we perceive rotational direction in distant galaxies. In this case, the anomaly wouldn't be a cosmic clue, but merely an artifact of human error, a mirror reflecting our own limitations rather than the true nature of the cosmos. And yet, the strange inconsistencies don't stop there. The same telescope that provided data for the rotation analysis has also been revealing galaxies that challenge every timeline laid out in the current cosmological model. Some of these galaxies appear to be too massive, too structured, and too mature for the age of the universe in which they're found. For example, galaxies like GS 140 and Z 141 are believed to have formed when the universe was just 2% of its current age, something most models consider highly improbable, if not impossible. Sears 109 is another such galaxy, notable not just for its existence but for housing a supermassive black hole far earlier than our theories can account for. Then there's HD1, an extraordinarily bright and distant galaxy that appears to be located at a redshift close to 20. If this observation is confirmed, it would mean that HD1 existed only 168 million years after the Big Bang. By all accounts, a galaxy of such size and luminosity shouldn't exist that early in cosmic history. These discoveries are leading some researchers to revisit an old idea that was once relegated to the fringes of theoretical physics: the cyclic universe. This concept, supported by thinkers like Roger Penrose, posits that the universe undergoes eternal cycles, expanding, collapsing, and being reborn in an endless loop. In such a model, the black holes we see today could be remnants of previous universes, relics left behind by cosmic phases long gone. If this theory is valid, then many of the anomalies we now observe, such as massive early black holes and impossibly structured galaxies, may not be anomalies at all. They could be evidence that the universe has already died and been reborn countless times. At the same time, another unresolved mystery looms large in the background: the Hubble tension. This is the name given to the discrepancy between two methods of calculating the universe's expansion rate. One approach measures the rate using observations of distant supernova, while the other relies on data from the cosmic microwave background. The problem is, the two methods produce conflicting results. Instead of clarifying this discrepancy, recent observations have only made the situation more perplexing. The inconsistency has become so stark that some scientists are now referring to it as a crisis in cosmology. Could this be a sign that the standard model of cosmology, the framework we've used for decades to explain the origin and development of the universe, is fundamentally flawed? Are we on the edge of a paradigm shift in our understanding of existence? The questions continue to mount, and the answers remain elusive. The telescope's ongoing observations are not just delivering beautiful images of distant galaxies. They are systematically unraveling the assumptions we've held for so long: galaxies forming too early, black holes appearing where they shouldn't, and now this strange directional bias in galactic spin. All these findings suggest that something about our universe is not as we thought. Is it possible that we are living in a universe that spun into existence from the death throes of another, much older cosmos? Or are these phenomena simply statistical flukes, coincidences in a universe governed by chaos? One thing seems increasingly clear: the more we investigate the cosmos, the more profound our ignorance becomes. Each discovery, rather than tying up loose ends, seems to open more questions. It's as if the universe is not just a puzzle to solve, but a riddle that deepens the more we explore it. Perhaps we are inching closer to some deeper truth, or perhaps we are merely peeling away layers to reveal ever more mysteries. What is certain is that we are standing at a turning point. This is not merely a new chapter in astronomy. It is a challenge to the very story we've been telling ourselves about reality. As our tools grow sharper and our reach extends further into the depths of space and time, the universe is beginning to speak in ways we never anticipated. Whether we are ready to understand it is another matter entirely. But the journey is underway, And there's no turning back now.